And I am recording.
Welcome, everybody. Welcome to the Haystack Live Meetup. Thank you all for coming. Today, we're going to hear from my colleague Max Irwin on natural language search for Solr and Elasticsearch. It's going to be a great talk, and he's got some things he's created to show you as well, which is going to be exciting. Just to add, we've got some of our open source connections training coming up soon. There's actually a Solr, think like a relevance engineer course next week. There are still some tickets left for that if you get in there quick. We have Learning to Rank coming in a few weeks on the 20th of October. That teaches you how to use Learning to Rank and on Solr or Elasticsearch. And then we've just announced a course on natural language search, which is linked to this talk on the 17th of November. So do check out our website for more details. As usual, if you have questions, please drop them into the Zoom chat, and I will moderate those when we get to the end of the talk. I'm sure Max will be happy to answer your questions. You've all very kindly muted your microphones, which is useful if there's any background noise. It's up to you whether you want to put your video on or not. And without further ado, I shall hand over to Max for today's talk. Thank you very much.
Thank you so much, Charlie. Just one more note, we are recording, if you didn't catch that already, so we upload these to YouTube. If you have to drop out and you can't catch the whole thing, you can come back and watch this recording or any of the other recordings that we have. Thanks so much for coming. The title of this talk is Natural Language Search for Solr and Elasticsearch. This is a pretty easy title. Other alternate titles that I considered were Natural Language Blunderstanding, because it's so ridiculously hard, and Natural Language Funderstanding, because who doesn't love NLP? So I'm Max Irwin, the guy talking to you right now. You can grab my contact information there. I am going to talk about a lot of stuff. We have technically an hour and a half-ish. I don't know how much time this talk is going to take. It's going to be a talk and then a demo of some stuff. But just some background on how I got here. I did some search stuff. I've done software development for a while. Did some search stuff. And I got into NLP around 2016, 2017, when I started figuring out how to fix a bunch of search problems that were really annoying. Then I joined OSC. I met OSC at Lucene Revolution, when it was still called Revolution. I met Eric and Doug back then, and I really liked what we were doing, and then they announced the first Haystack. So I gave a talk on some of the research that I'd been doing about vocab extraction, and that talk, the slides are available, there's no recording, but that's still a popular talk, and I refer to that pretty often. So that's really how I started my research, because I was mostly interested in taxo development and extraction using NLP tooling. And then I continued my research and I joined OSC, and I use NLP for clients here and there when I have the opportunity, but it's always interesting to me, and I always try to solve search problems with it because it's a very effective tool. And based on my experience and basically the explosion of stuff that's been going on in the NLP space in the past several years, I developed a course. I gave it in pieces to a client of ours, a rather big client. And we are offering it publicly now as well. This year I started working on a project that really renewed my interest in the talk that I gave at the first Haystack, and a whole lot of other stuff. It led to an interesting direction, and we're all here today. So thanks for coming, and let's get started. So we have a pretty ambitious agenda for this talk. What are the problems that we have as Solr/Elasticsearch users? There are people from both camps on the meeting today. Please, no fighting. You know, we're all friends. But Solr and Elastic are both based on Lucene, as most people know. And there's a lot of stuff that goes on in Lucene, and we've picked up a lot of habits over the years to try to do things in fancy ways. But we get stuck. So what do we want our search stack to be able to do? And how do we express those wishes as existing solutions that are out there, but they're not really tied to search just yet? So how can we take those and put them together in a way that complements what we're already doing and doesn't break a whole bunch of stuff at the same time? So the big problem statement is that full text search fails for many use cases, even when tuned. So what do I mean by that? So if I like to picture Lucene as like this amazing math nerd who's been handed a whole bunch of books, and they're like, but I didn't pay attention in English class. I spent, I got my PhD in computer science and math. So don't bother me with these text things. I want to parse strings and numbers. So if you send a query to Lucene, shirt without stripes, I want to search this query. Lucene will just do matching and weighting with complex mathematics and data structures. It doesn't really understand anything about that, and that's not a surprise. Everybody knows that already. But how do we solve this problem? Because this is a common thing that people search for. Maybe not this particular query, but people want to express themselves in even these short fragments of sentences. Not just the keywords, but even just a little bit of hint of like, no, this is what I want. So how do we solve those problems? There's a whole bunch of other problem statements, and I'm going to spend a little bit of time talking about all the problems that we have. It's very important to express these things because we all live with them. You install Solr or Elastic, you index some content, and you start searching, and it stinks. And you got to spend a whole bunch of time fixing problems, and eventually you mature, and it turns into this big configuration mess with a whole bunch of stuff going on. So you really have to spend a lot of time to fix seemingly trivial problems that I said before. Because Lucene doesn't grok language, and the other problem is that engineers, there's all this obscure knowledge scattered around the internet and in people's brains, and we go to talks and we look on Stack Overflow and we go dive in the documentation and we look at the actual source code that's in GitHub, and we try to piece all this together to how to solve our problems. And there's this other camp. There's all these NLP libraries out there. There's company Hugging Face, and there's the Explosion AI team with Spacey, and they're doing all this cool stuff, but it's low level from our perspective because we spend a lot of time doing configuration in search. We don't spend a lot of time actually writing code in the search engine layer. We do in the service layer. So it's not really trivial how to put these things together. And of course, you can give your money to Amazon or Google, and you can say, okay, I'm just going to send my query to you guys and give me back something good. It's expensive. Do you know if it's working? If something goes wrong, how do you debug it? Are you willing to give up that control? So a lot of us, especially OSC, our mission is to empower search teams. We talk about making sure that people have the tools that they control and they understand so that they can solve the problems that they have for their customers. So a lot of teams end up building or buying all this stuff to go along with your stock Solr Elasticsearch system, right? So you need your service layer. You got to, cobble together some auto suggest stuff. You got to write all this query logic. You got to do your content enrichment and text pre-processing. You got to worry about your taxonomies and your synonyms and all these things. And so many teams end up either building these things themselves or buying these things one at a time and cobbling together something custom for themselves. And then, unfortunately, there are a lot of teams out there that don't really have the time or the budget to be able to do that. So they slap a search bar on their page, they stick some content into a Lucene-backed engine, and they're like, okay, we got a search working, we're getting 10 links, we got some facets next, but then their search is terrible and they don't have time to spend on improving it, right? So that's a huge problem that we see in the field. And now we get into the technical problems, right? So Lucene normalization and analysis chains. If you want to deal with text, you kind of just can't. You do your best, and these tools are very, very fast. The the analyzers are easily configurable, and you can do a whole bunch of stuff with them in the pipeline. But there's something missing, and everybody knows there's something missing, and you do all these kinds of workarounds, and you're like, oh, don't stem that term, and oh, this is, don't split on this hyphenation, this is a compound word, and all kinds of other funny and interesting stuff that we have to deal with day to day. And if we want to get advanced and we want to write some plugins, Solr, you can have OpenNLP inside of Solr, and you can stand up an NLP-based plugin in Solr. But then, like, every time you re-index, well, now you've got this really heavy thing that just slows down your re-indexing, right? So it's like this double-edged sword. It's like you can't fix the problems in your search engine, but you want to. The other problem is that all the NLP research, open source NLP research, is really advancing in the Python world. It's not advancing in Java. There are Java tools out there, and they're good. But if you talk about all of the things that are happening and you see all of the activity, it's pretty much Python based because of the tools that Python affords and all the deep learning frameworks that are out there supporting Python in the Python community, right? So these are the tech problems that we got to deal with. So let's look at a typical analysis pipeline. Okay, you've got some content. It goes to your HTML strip char. Maybe you want to do a pattern, a char replace filter. You want to, maybe find some, currency or something and, fix the $sign or the period or something like that. And you got this whole bag of regular expressions. And now you got to tokenize, and you got to make sure that tokenization is doing what it's supposed to do in the right place. Then you got synonym expansion, and, what if your synonyms are picking up the wrong things in certain places, and now you got too much recall, and you got to deal with that. Stop word removal is like a huge pet peeve of mine. I just hate removing stop words. You're just throwing away stuff in your text, which is bizarre to me that it still happens, and we still have to do this in certain cases. Lowercasing ain't no big deal, but that's a funny graphic. And stemming, everybody knows the pitfalls of stemming. It's just horrible. You get things that end up matching that really shouldn't in the end. So this is what an analysis pipeline looks like these days. You open up most Elastic or Solr configs, and this is what you're going to see for a field, a text field. So what if, we've got this what if, and there's a whole bunch of words in here. There's a whole bunch of things. What is semantic markup awareness? What is statistical pattern recognition? What is coreference resolution? But we have all this stuff. So what if you have HTML and you don't want to just throw out the HTML, but what if you see something and it's like, okay, well, this term is in bold in the markup. Well, that's important. Should we just chuck it out? What if we had a way to capture that and understand and say, well, this is a bold term, so we're going to put some weight behind it. What if we had, instead of just a whole bunch of bag of regexes in our pipeline, we could actually do some more advanced pattern recognition with stats, right? So there's a tool called Duckling, which is now it's the Facebook team, but it was from a team called the WIT AI team. And it's a Haskell service, and it does a really good job of finding patterns. It is a bunch of regexes, but it's mixed in with some naïve-based classification and some other interesting things to get some better accuracy out of it. Coreference resolution is an open problem. I'm going to talk about that a little bit more, but that can really help in a lot of use cases. Tokenization, we're just splitting terms on white space, typically, maybe some other punctuation and some other things. What if we could, understand what sentences and words looked like and how they relate to each other and what their context was? And what if we could use that for further things? Synonyms, what if we had a knowledge graph and we wanted to extract entities and use those in our search? And then what if we wanted to classify a document based on stuff? You can use term vector classification tools in Solr and Elastic. They're out there, but they're the result of a lot of the normalization that you've already done in your typical analysis pipeline. And you can do some base classification and some other things, but what if you want to do some really advanced stuff, based on some transformers? What if you want to write your own deep learning model? You want to use like Jensen, which is a great Python library for doing these things. Stop word removal. I hate removing stop words. What if you could just weight terms? Like the term the is not worth much. So don't throw it away, but just say it's not important. So if you get a match, you're not gonna boost on it. Maybe you'll deboost on it. What if you don't have to stem anymore? What if you do lemmatization? We'll talk about that in a minute. And lowercasing, you can do that. Blah, 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 blah. So I didn't finish this slide, apparently. That's funny. But you have all these text things that you want to solve. What if somebody searched for 1992 Supreme Court decisions? Are you just going to match the text on those, or are you going to try to understand, well, I want to filter on 1992? How do I do that? And there are a lot of other examples where you have these like short, not whole sentences, but queries, like natural language queries that you want to deal with. So stemming, again, we got main points to MAIN, and then if you search for main, MAIN, you're going to get a hit. And then hiking, you're just chopping off the ing. Lemmatization, you're actually using a vocabulary to look stuff up. And this is available in most NLP libraries. I'm going to talk a lot about Spacey. I use Spacey a lot. But Spacey will lemmatize nouns and verbs and all kinds of stuff for you. And it works really well and it's really fast. If you do this in the index, and I used to do this in the index, my previous company, we had a huge Solr index where we would do lemmatization, and it was really slow because we had this gigantic dictionary that we'd have to maintain, and then we'd have to parse stuff as it was coming through the analysis chain, and it would just bog down when we were doing a reindex. So it would have been nice if we didn't have that problem. So I'll talk about how we're going to solve that a little bit later. All right, coreference resolution. So this is a big one. So I'm going to give two cases for coreference resolution as a tool. The first tool is, since I do, a main area of my research is vocabulary extraction, I want to see the relationships between terms, right? So I've got this sentence: when choosing to install Solr, there are several options. It can be downloaded from the Apache website or the Docker Hub, right? So what is it? So now I've got this thing, it. Now there's a lot of meaning behind this term, but I don't have a way to hook onto it. So I want to have predicates that are related to the noun Solr as part of some vocabulary extraction work, right? And I want to see how terms relate to each other. Well, in the first case, I just get the first one, install Solr, right? So I can do that. But now if I do coreference resolution, I replace it with I've got the prenominal, I replace it with the noun, and now I have Solr is replaced in place, and then I can do further work on it, and now I've got this further relationship, Solr download, right? So that's really interesting. Another really interesting byproduct of coreference resolution is BM25. So BM25 is meant to measure the aboutness of terms in documents. You want to know how important is this term in a document compared to all the other documents, and give me the ones with the highest score up top, right? So let's say we've got these two documents. So some search teams use Solr, others use Elasticsearch or Vespa, right? Now I've got document 2, which is the last case. I'm choosing to install Solr, yada, yada. So if I query Solr here, the first document comes up as the top because BM25 says so. So I can see that the saturation is much lower on the second document. This is a much longer sentence. The term frequency is the same. But this document, the second document, is about Solr. The first one mentions Solr, it mentions a bunch of others, but the aboutness is really in the second document, right? So now if we do coreference resolution, this fixes that BM25 issue. So now we've got term frequency of 2, we've got a higher saturation, and now the second document is going to come to the top as we want, right? So that's a really interesting tool. Unfortunately, the accuracy isn't amazing. I believe the leaderboard right now is about 79 F1 is the F1 score from a paper that was maybe 6 months ago to a year ago. But that, people are working on this a lot. And there are some tools that kind of do an okay enough job where you can fix a lot of annoying issues. Okay, so another tool we have is payloading for linguistic weights. So this is not an original idea. This is pretty common. I know a lot of teams who at least discuss this, whether or not they do it. There are a lot of examples out there, mostly in Solr. I haven't come across too many Elastic examples. But the idea here is, well, if I'm searching for chocolate, how do I identify chocolate, right? So I've got this first document, Nestle chocolate milk, and then I've got Nestle milk chocolate. Now these are equivalent in BM25, right? If I search for chocolate, I'm going to get the same score for both of these. But the latter is chocolate. I'm searching for chocolate. I'm not searching for milk. And this is a concept called the head noun. So here we will payload a weight based on its semantic importance in the text, right? So now I'm going to payload 2.0 because this is a head noun. So I'm going to give this a little bit more juice. And then this one, chocolate, that's a 1.5 because that's a modifier. I'm not going to give it as much. So now I'll get this document will have a higher score because it is chocolate. It's not milk. Named entity recognition. I'm not going to spend a whole bunch of time on this. This is covered extensively, but there's a whole bunch of things that we could do with NER. And a lot of people want to do it, but there's a lot of problems with it. At the very least, it's pretty easy to just identify noun phrases and people and locations. You may not be able to link them to a knowledge graph or a database successfully without doing a lot of manual work and cleanup. But at the very least, you can say, well, this is an entity, it's important, and it's important in a certain way. And I'll show some examples later, but basically you can say, well, give me all the people from a document and stick them in a people field so I can facet on the people or filter on the people, which is a common problem. Or locations. Text, and text converted to numbers. What if I say like $12, I spell out 12? And I've got like the $1, 2. Those are the same, and I want to be able to find them in the same way. So that's a recall problem, and that's pretty important. Knowledge graph extraction. This graph is an example that I'll show a live demo of this later, based on a tool that I originally wrote for that talk in 2018 called SkipChunk, and I've had the opportunity to refine it in the last couple months, and it's coming along pretty well. So it does some really interesting things. We'll see a little bit of a demo of this later, but basically it finds subject, predicate, object triples in unstructured texts, and it stores the relationship in a search engine. It doesn't use a graph database. It just uses Solr or Elastic, whichever one you want to use. And then you can navigate this graph and you can see term weighting, relationship weighting, and very interesting things to give your language more glue. Query intent and rewriting. So shirt without stripes. If I search for this thing, maybe I'll have a rule set that I want to follow. I want to say, well, I've got some prepositions and I've got some rules that follow those prepositions. If I see without and then a noun, I'm going to be like, I don't want that. Filter it out, get rid of it. I don't want this. So I will rewrite the query and say, I'm searching for a shirt and I don't want stripes of the style of the shirt. And this should be a flexible tool for you to use. It would be really nice if you could do this in a really, really easy way. But it's not easy right now. It's hard. So this is like a dream analysis pipeline, right? I've just thrown in a bunch of examples. There are a whole lot of other things that you might want to be able to do. You could do and I'm going to say it. I'm going to say BERT. I'm going to say the BERT word. You could do the BERT thing. You could vectorize your whole text. You could stick it into a vector field. You could vectorize your query, and you could do approximate nearest neighbor if you wanted to do that. A lot of people are trying to do this. It's hard. There are a lot of problems with it. We'll see how this plays out, but there are a lot of smart people working on this problem. You know, Google and Bing and other folks, you know, they got plenty of money, so they're throwing it at it, and they're having a lot of success. But if you don't have a full-time data science team who can do fine-tuning specific to your domain, and also a full-time DevOps team that can worry about model GPU performance and where you're going to store all those juicy vectors. You know, you're going to have some trouble if it's like you and 3 other folks who are trying to engineer a customer-driven solution. So all of those things that I mentioned, you know, you want to do them, but if you do them again in Solr or Elastic Analysis Chain, you're just going to slow everything down. It's going to be like, oh my God, I have to reindex. Please don't make me reindex. I just want to change the rating for my product. I don't want to reindex and deal with everything. I want to keep attributes up to date, and I want to change stuff, but I don't want to reindex every single time I make a tiny little change because it's just going to take forever. So I want to do enrichment outside of the search engine and keep it somewhere so that when I do reindex, I only have like some very, very fast things that I have to worry about. Solr Elastic tokenizing, lowercasing, and you know, if I got some payloads in there or something else, you know, delimiting is pretty quick, right? Maybe I'll have some other things in there too, but all of the big like NER and coreference resolution and all that fancy stuff, you do not want to do that in your field type. That's going to cause you pain. So there are solutions out there, but we are not academics. We are practitioners. And Answerini is amazing, but ask me how long it would take me to get a robust Answerini solution in place if I just want to use some quick tools. I don't want to read an academic paper to figure out how to connect it to Solr Cloud. So what do we want? As practitioners, we want practical tools so we can quickly ship better search quality. We have a lot of tools already. We have things like Cupid. We have Rated Ranking Evaluator. We've got a bunch of stuff that we're using to measure search, and now we want to improve it. Most of the improvement happens either in your custom service layer or in the analysis chain. I'm so tired of seeing, going to websites of tools and saying it's going to automatically fix my relevance problems for me. You have no idea what my relevance problems are. Please don't assume that you can fix them. So if I go to your fancy cognitive search tool, I know that you're not telling the truth. When you say cognitive intelligent search is going to solve all your problems, it's not. I still got to spend a lot of time, and now I got a black box to deal with. So that's trouble. I want something that is a natural extension of my existing search engine. I want something that works with Solr and Elastic. It works with the other tool sets that I'm already using. And it's non-intrusive, and I can have additional signals and analyses that I can use if I want to use them. You're not forcing anything on me, and it's flexible. So I have been working pretty hard in the last couple months on a service that I've developed called Hello NLP. This is an open search service. It's an example service. It's not the end all be all, but it embodies a lot of the things that I've been talking about, where it's been pretty tricky to marry these technologies together in a nice way that does the things that I mentioned on this wish list. Again, these are the things that drove kind of my dream service. You know, if I was going to write something from scratch, this is what I would do. So I did it based on working with a lot of search teams and seeing a lot of the same problems all over the place. So I pressed the public button on GitHub this morning. So now it's public. So you'll see, you can go to the link here. I'm going to give you a demo right now, but it uses a bunch of things. So it gives you out of the box NLP-based autosuggest. It gives you pipelines for NLP that look very similar to your Elastic or Solr pipeline. The configuration looks very, very, very similar. You should be very comfortable with it if you're used to configuring those tools. And it does query enrichment that lets you pass in your Elastic DSL or your Solr query string, and it will enrich it in the way you tell it to. So it's just like writing a Solr or Elastic query, like you're used to. There's no special magical new query language that you have to learn. There are a couple decorators that I've added that can help, but you don't have to use them. Okay, so now I would like to offer this USB stick to the demo gods. Please, demo gods, be kind to me while I give a demo. All right, so I'm not gonna start with the tool itself. I'm gonna start with Splainer. If you're not familiar with Splainer, it's an open source tool that works with Solr and Elastic. And it lets you craft a query. This one happens to be in Solr. And it lets me craft a query, and it lets me see the scoring and how the scoring is happening, and it lets me tune. So I've got this query search quality. It's an Edas Max query. I've got some query fields with some boosting, and I've got some payloads. Well, this is interesting. So what's happening here is I actually have payloaded some linguistic weight, and I can hook into that. And this is a Solr subquery, nothing special here. This is out of the box. I can use this, but I've enriched my content with Hello NLP before this. So now I have the title field and the content field are payloaded, and I can use the payloads to boost, right? This is a common example. You can grab this stuff off the internet. So if I go down, sorry, I'm gonna change this. I'm gonna say payloads, and I'll rerun my query. So now I can see what's really happening. I have this as a stored field, so I can look at what's being payloaded, but I can see all of the fancy weights have been added to my query, to my content, sorry. And then I can hook into that. And that's nice. So how does this actually work? How do I actually get this content in here? Another thing, if you notice, this query, I'm not pointing this at Solr. Well, you might not notice this because this looks like a Solr URL, but this is actually Hello NLP URL, which I'm hosting on my local machine. And that's not what you're supposed to see yet. Okay, so this is Hello NLP. So this is the Solr configuration for Hello NLP. I also have an Elastic configuration right here. So this port at 5055 is running against an Elastic Docker that I have. And this port 5050 is running against Solr. And I think my Elastic is version 7.9, and my Solr is 8.4, I think. And on the right, you see this interesting thing, the pipeline. The pipeline is actually the same for both. I have them both configured the same way. I've got a plugins path. I've written some Python plugins that I can add. It's very easy to write plugins for this thing. And I've got some analyzers. So now I say, well, I've got a payload analyzer. So this looks awfully familiar. This is an HTML strip. This is a tokenize, and this is a payload. But this isn't what you think it is. HTML strip is actually using the LXML library in Python to parse HTML, not just throw it out. I spent a little bit of time looking at the HTML strip char filter in Lucene, and I got into some interesting code. And it's actually a flex grammar that was written specifically for stripping HTML out for a wide variety of use cases. And I took all the tests and I ran it against LXML, and some worked better and some didn't work as well, but it produced some great results, and it's really fast. LXML is, I think it's C-based, that was wrapped by Python, and it's pretty straightforward to use this. So I could parse the XML or the HTML, and I could do the things that I was talking about before. So I don't have to throw it away. I could look into the bold tagging, and I could do some other things with it, and I could add weighting to terms. The tokenize is not like a white space tokenizer or a standard tokenizer. This is Spacey. This is a Spacey pipeline. So if you're not familiar with Spacey, it's an NLP library that's written in Python, actually Python, and you can pass text into it and you get cool stuff back. So that graphic that you saw before of you know, the relationships between text, that was a spacey tokenize. And then the payload. The payload is basically looking at the dependency parse for what spacey gave me, and it's attaching weights. It's just doing the payload delimiter filter factory. It sends it to a field that I've configured in my schema, and it marks it up and it sends it in there. So now I've got some other analyzers too. So I've got entizer, and this does entity recognition. This actually pulls out people from text. Lemmatizer, so you can lemmatize stuff. That's pretty straightforward. Prepositionizer, so that shirt without stripes example, we could do that. And then I've got fields. So let's say I want to enrich a document. So I can send a document in, and it'll take these fields, and it'll say, oh, title, I'm going to run it through the payload analyzer and copy it to title payloads. I debated whether using copy fields for this API, but this seemed pretty natural. You can repeat the field if you want. So content goes to both content payloads and the people field. So it's payloading the content, and it's also stripping out the people and sticking them into this people SS field, which is a multi-valued string in the Solr config. And then I've got a basic query enrichment, which is just lemmatizing, right? So I have all these analyzers, and this is nice, but what are they actually doing? So another big thing for me is, again, I want to be able to use the tools that I have access to as if I were a normal relevance engineer, right? So if you're in Solr, you can use the Analyze API UI in Solr admin. There's a plugin for Elastic, the Analyze API plugin, which will visualize, but you can get the JSON back because Elasticsearch will happily analyze something for you and spend it back. So let's say I've got this text here. The quick brown fox jumped over the lazy dog. Great. So I've got my analyzer. I'm going to simp the query, and I get it back. And I'll just make this a little bit smaller so you can see the whole parse. But we see, okay, well, here's the result. So I've got the quick brown fox jumps over the lazy dog, and I've got weighting behind this. So you can see fox is 4 because this is a head noun, and dog is an object, right? So the head noun gets the 4, dog gets the 3.5. And the other really important thing that we will have to deal with is how long does this stuff take, right? I challenge you to figure out exactly how long each pipeline stage takes in Lucene, unless you really dig in and find out. So I wanted to be able to know very quickly where the bottleneck was in something that I'm doing. So it turns out that tokenize is actually quite expensive in this case. It takes 42 milliseconds to tokenize that text. Spacey works well in that it will cache things for you. And if I run this again, it might be a little bit faster, and it was. So now I've got 12 seconds. And now I've got this parse, and I can use this parse. So now I want a payload, and the payload just drops the weighting in there. And I've got some rule sets. And now I'm going to show you some code, which is really scary. But where's my Sublime? So that's that. Okay, so this is my payloader. I've just defined some weights based on open classes. So if you're not used to NLP stuff, check out Universal Dependencies. We'll tell you a lot about the parts of speech and things like that. It's kind of a rough website, but the information is there. You just got to dig for it. So I want to just assign certain things in certain ways. So I'm going to bump my part of speech tags in this way. So if I see a verb, it's going to get a 2. If I see a noun, it's going to get a 2. Proper noun, I'll get a 2. If I see the root, which is the head, I'll add another 2, right? Which is great. So now I see all this stuff, and I'm going to give some juice to my tokens, and I just go through this, and there's all this other code, right? But it's not that much. It's a little bit. And this one comes with it. I'm not pitching it as a plugin. It's just a standard analyzer. So now we have this. So let's look at some other things. So I mentioned the entizer before. So now let's say I say Charlie Hall introduced Max Irwin for the talk. Submit query. And, oh, sweet. I thought it died for a second. So here's the result. Charlie Hall, Max Irwin. Boom. This is Spacey NER. This is pretty straightforward to do. It doesn't take very long. That was 7 milliseconds. And now I've got this and I can do whatever I want with it. So if we go back to our pipeline, I can see that, well, I've got a field that says, well, for content, I want to do the entizer and I'm going to stick that output into the people SS field. So this is the Solr stuff, but it's also working with Elastic. So I can do the same thing. So this is my, again, Elastic instance. I'm pointing at Elastic. The analyze, it's not touching the search server. It's just running the same stuff, but I can send I can send content to this and it will index it for me. We'll run it through the pipeline and do it. So there's a pretty extensive API for this and it's all here. It's fast API. The whole thing is a Python service. I'm running it with Uvicorn, but there's Docker. So that's the other important thing that I wanted to mention. The tooling is important in that it matches the way that we use tools. So if I start with something low level, I have to worry about the service layer and I have to worry about deployment and I have to worry about all this stuff. So I want to make sure I understand the performance and I want to make sure that I can deploy this thing in a way that I would use. So this is a Docker container. If I want to set it up in Kubernetes and deploy a whole bunch of these things to get really fast throughput, you know, I want to have 10 reindexing Dockers and I want to have, 5 searching Dockers. That should be easy to do, right? You shouldn't have to write that stuff from scratch. So that was another goal of this project, is to make it really easy to deploy. Now I'm going to talk about the graph that I mentioned before. So we have this autocomplete. So it doesn't go through an analyzer yet. It's in Skipchunk, which is a command line library right now, but the connectivity to Solr and Elastic works the same. That's shared. But I have indexed the OSC blog. So if I start typing search, so I get interesting results, but what you'll notice is that these things are noun phrases and verb phrases and things like that. You're not going to get all the garbage that you would get with configuring an analyzer, configuring an auto suggest or a suggester based off of the normalized text that you would do in a pipeline. You could do engramming and all kinds of fancy things in Solr Elastic, but you're going to pick up a lot of junk because it's not isolating the importance of the words. So with Spacey, we know that words are nouns and verbs and adjectives and adverbs and a whole bunch of other things, and they relate to each other. So we can use that to pull out concepts and put some stats behind them and then relate them. So the other thing is that we, as we parse sentences, I can say, well, users. So I'm going to click on users, and now I'll zoom in a little bit here. But this is the relationship graph that you're seeing. So I've got users search queries, and users search terms, and users have everything apparently. But these are the relationships that are in my text. So this is a latent knowledge graph that I've pulled out, and I'm expressing it here. And this just runs off a very simple schema that I've created. Again, both Solr and Elastic, it'll work in either. And it stores this information and you can use it in a number of ways. I guess, ultimate goal of this would be able to edit these relationships because you're going to get a lot of noise and things like that you're not interested in. Text is very, very messy. I also want to have an opportunity to add synonyms through some kind of UI because the text is the text. It's not doing any magical thing. It's not doing any kinds of fancy embeddings to relate terms to each other because that doesn't work too well in a lot of cases. So it's just raw text right now, parsed with Spacey. So you want to be able to say, well, learning to rank is the same thing as LTR, right? That's a synonym. It's a different label for the same concept. And I want to relate the two together. So that's like a really far out stretch goal for me to be able to do something like that. And then be able to use this when I'm searching. And if I search for something and I want to autocomplete And it doesn't do this yet, but it wouldn't take long for me to wire up something where I type users, and then I press space, and then it gives me, if I don't select one of these things, it'll give me, other nouns that would appear close by to it, right? Other nouns that appear in the same sentences, or other nouns that appear in the same, with the same verbs that connect the two. So it's actually pretty easy to do that based off the data structure that I already have. I just haven't spent the time to write up the UI. The API calls for that exist. So I'd really like to be able to do that, and that should be really nice. Because people type and they want suggestions of things that are possible. You don't want to suggest something to somebody that is going to result in zero documents. And you want to suggest things that are going to provide the most relevant content to them. Okay, so let's get into some deeper areas here. So I have a couple basic examples. I talked about the payload boosting already, but now I'm going to talk about query rewriting. So if I open this explainer link, you're going to see something very interesting. So I actually have two filter queries here in Solr. This is a filter query. And this is a subquery where this is just a very, very basic syntax. This is pretty minimal at this point, but it's very expressive. And it lets me say, well, I have this analyzer, it's called a prepositionizer right now. I'm not great at naming things. But that looks like this. So I'm going to go back and look at some more Python. Apologies for the code. So I've got a couple plugins that I've written. So let's look at the prepositionize. And this is just a very, very simple Python plugin. So you could take this, you could copy it, you could paste it, stick it in the plugins directory, and boom, you've got a plugin that you can use and craft any rules that you want to. In this case, I'm just doing something very simple. So I have this method propose, and I just pull out all the prepositions and the prepositional objects, and I say, well, in the query shirt without stripes, without is the preposition, the p-obj is stripe, or stripes. So I say, well, give me those, and if without is in the preps, then rewrite the query to get rid of these preps and p-objects. So now I'll just be left with shirt, and the value that I want to stick in my ultimate template is the V. So if I go back here, you can see that I have this $V, and this looks like a Solr query. So this is just a very, very simple query preparser that does this for you. But the syntax is very, very familiar. And I actually stole these parameters from the payloader, right? So you have F and you have V. V is $Q, which references this. And then I've got this filter, which is, I don't want to see stripes. So this is going to be relevance without controlling. So if I remove this, I have this thing at the top, right? So Solr versus Elastics for relevancy, controlling matching. I don't want that. Stop telling me about controlling stuff. And now I get this document because now I'm actively filtering that out. So some more, and I'm kind of jumping around a little bit here, but some more things to note is there are a lot of interesting things that you can do. You can do the analysis, you can enrich a document, you can index a document, and you can re-index a document. So if I call enrich, it's not going to store the document on disk for me. It's just going to give the document back, the enriched form that I've specified in my pipeline. If I say index, it's actually going to store the document on disk, and it'll keep it there. And there's no cap theorem here. If I've got 10 systems in place already, all doing this stuff, I have not gone to the point of implementing the Raft protocol to make sure documents are safe and all that stuff. This is very basic at this point, but it will store the document for you on the system. And then if I call reindex, all of the documents that are there on this system that I'm calling reindex on, it will just send them right back into the search engine. It doesn't touch them. Another API call that I want to have in here is like a merge command where I can say, I want to merge these attributes that I've got with the document that you already have for me. So you don't have to re-enrich it. You can just take, my product ratings, my product star rating, and update the product star rating field on that document. And that should be pretty easy. So it's not a hard thing to do. They're stored on disk. There's no special database. That probably needs to be a bit more robust. This also works with Cupid. And I want to give a shout out to the guys at Amboss, who I was actually right in the middle of writing a Cupid pass-through query for Elastic. I had it done for Solr, where I could talk to Solr from Splainer through NLP, through Hello NLP. And I could talk to Solr through Hello NLP from Cupid, but I was just starting on Elastic when the folks at Amboss, they released the Cupid ES proxy code, which is on GitHub. So I took some inspiration from those guys. It was an MIT license, but I left the copyright in there because they deserve full credit. So I've used some of their API calls here, and they work pretty well. So now you can use Cupid with this. So if you don't know Cupid, it's a relevance judgment tool that we developed at OSC. It's open source. So that was an original goal. Again, make sure that the tools that we have work with this stuff already. So that's been almost an hour. I do have a couple more things to say, but that's the end of the demo. Again, you can download this thing. Let me go back into presentation mode. Thank you, Demo God. You were kind to me. So conclusions. Use NLP with search. Do that. If you're brand new to NLP, and you want to get started on your own, there's a free Spacey course from the Explosion AI team. Inez, who's an amazing contributor to the community, she wrote this course. She works at Explosion AI, and it's really, really good. So if you're just starting off with Spacey, go take this course. It's very, very helpful. It's helpful in the way that it teaches you the API of Spacey. It doesn't teach you like use cases, like real world use cases. There are some good examples, but the use cases that you and I deal with day to day as search practitioners, those aren't really covered there. So for that, we have the natural language search training. If you are interested in NLP and using NLP with search, I talk about a lot of the concepts here. I talk very heavily about measurement and how to understand if NLP is working for you or not, because these things are models and they're complicated and they're not foolproof. And you have to make sure that you're doing stuff right, because otherwise your accuracy is going to be off. I also get into the whole transformer stuff. We talk about vector search, and we actually end up as the final lab writing from scratch a vector-based search engine, an NLP and vector-based search engine in pure Python, which is a very, very illuminating experience, because then you really, really learn the pitfalls of this stuff and how to wield them in the ways that you need. If you are interested in this project, please go visit the Hello NLP source and take a look. The glue is like just kind of drying. It's still in the clamps. So it's not like, don't put it into production. And, if you've got 1 million visitors per day, don't like stick this thing in production right now. But it's definitely usable, and it's definitely usable for experimentation. The API isn't 100%, so I've labeled it 0.9. I want to do a couple more things before I get to 1.0, but it's labeled as beta right now. So that's where we are with that project. And now I'm going to open it up for questions.
Thank you, Max. That's fantastic. We've got a couple of questions first on the chat. I've got Alex's question. Alex, do you want to re-ask your question? Alex Rafanovich?
Yeah, sure. I mean, it's there. I was just trying to understand whether this pipeline is index only or index and query. It seems both, but
it's both, and you can set up The pipeline is just JSON, so you can create any analyzers that you want in Python and then reference them in the pipeline and use it at query time or at index time. If I actually go back to the demo.
Okay, if I can just clarify, like how much could I get out of it by it being just indexed? Because I could index offline and not worry about it being 0.9, but then if I wanted to point to production Solr, with a, you know, like how much am I gaining from just index time?
Oh yeah. I would recommend that at the very least you would lemmatize a query, but you don't have to use this to do that. The thing with lemmatization is a big part of fixing a lot of the problems that we have in search. You will, in theory, get lower recall, but you're not going to get nearly as much noise. So my recommendation is, sure, you can use it and you can do the payloading stuff. So you could payload and you can do the entity extraction and all those things and just point your search directly at Solr. Like you don't have to go through Hello NLP. But if you want to lemmatize to get matches on the lemmatized terms that you've enriched, then you would probably want to use either this or just lemmatize your own using Spacie or some other tool. Like, you know, if you're using another stack and not Python, you know, if you're using Java, for example, you could use OpenNLP and lemmatize. It's probably very, very close. Test that first before you do it for real. But yeah, so you could use this as purely just content enrichment if you wanted to. And you would get a lot of value out of just the payloader and the entity extraction. You could also write all kinds of other language things, or you could write a classifier in Python, or you could do whatever you want. You could say, well, oh man, I've got these 18 content types and I got 1 million documents. I want to classify each document against this content type. I don't want to do that in Lucene or Solr or Elastic. So you could, you know, stick Gensum in here or something and write a classifier. That's very, very straightforward to do. Wow, somebody's drawing. Cool.
Didn't know we allowed that. So thanks for your question, Alex. David Rhodes, do you want to re-ask your question?
Sure. Thanks, Max. This was really, really interesting. One question I had is at the beginning of your pipeline, you have the HTML strip step, and was wondering if that is extensible to XML in general, that instead of just looking for HTML tags like bold, that if I had XML tags that are important to me, that I could weight those.
Yeah, absolutely. So one thing that I want to, so the short answer is yes. This uses LXML, which supports XML, not just HTML, out of the box at least. There's also some other things that I tried with, like Beautiful Soup 4 and some other, and then just the native Python HTML parser. But LXML will definitely parse the XML for you. I haven't messed around with using a schema like an XSD or anything with this yet. But again, it's just Python. So you could write an analyzer to do whatever you wanted to do in Python. And as long as you're outputting either text or Spacie tokens or lists or dicts or whatever, and your next plugin and your next stage in the pipeline, the input matches the output so you can chain them together. And there's no, it's not like Lucene where you have like a token stream and you have to always conform to the same token stream. You could write whatever, you could go hog wild and duck type and go crazy nonsense with this stuff. And you can have all kinds of crazy objects that connect to each other. It's just Python, right? And then you're bound to like making sure that it's doing it in the order that you specified. But you could very easily parse XML using your own schema and do whatever you want to do with that data and just send it on down. Eventually, you're going to have to output text at some point to give it over to your search engine.
Fantastic. Does that answer your question there, David?
Yeah, thank you very much.
Wonderful. So we've got no more questions in the chat, but if anyone else has got a question for Max, feel free to unmute, put your video on and tell us your question.
Yes, it's Alex again, if I can. I was just curious about comparison to Quirky. I don't even know how it's spelled again.
Oh, yeah.
Because they did it as a search component and kind of inline and so on. So seems like semi-complementary, semi-competitive? I was, yeah.
Oh, it's absolutely not competitive. And I should have mentioned Quirky before. Renee Kriegler, the maintainer of Quirky, has written an amazing tool. And this actually really complements Quirky because you could do a lot of the NLP pre-processing to like line things up and then manage rule sets in Quirky, which is really easy to do using either Quirky rule sets that you write manually or using the Smooey tool. I actually thought about throwing an example in here where that might work, but I didn't have time before this talk. So yeah, you could definitely pre-process your query in such a way so that Quirky can pick it up to do a lot of other cool stuff, because Quirky works really well already with like the eDismax parser and the Dismax parser, I think, in Elastic.
Fantastic. Hassan has a question. Is it possible to use Hello NLP with different NLP packages instead of Spacey?
As long as it's Python, sure. You could do whatever you want. I didn't show any examples, but you could spin up Hugging Face transformers is one thing that I want to get to eventually, where it does a vector search with Elastic using the vector fields in Elastic. I didn't have time to get there, but as long as you have something that's written in Python and you want to use it, go right ahead. The tokenization is written in Spacey. If you don't want to tokenize with Spacey, you could write your own tokenizer using NLTK or something else. It's totally up to you.
And Vincent asks, does the HTML strip keep meta or other highly significant HTML tags? I guess that depends on the library you're using.
The way that it's written now, this doesn't actually keep any tags. It throws it all out. You could very easily write like, I guess, a scraper or whatever you wanted to call it to look at an HTML document and say, oh, this title field, I want to use this as my document title, and I'm going to send it over here. And oh, this is a meta description, so I'm going to use that as my summary field or what have you. That should be pretty straightforward.
Great. And Alex has another question. What about noun phrases instead of just head nouns?
Yeah, so that skip chunk actually does noun phrases, and you can chunk in Spacey also. I'm not crazy about the chunker in Spacey because it includes determiners. So if you have, the Haystack conference, it'll keep the, where I think that should be chucked out. But the skip chunk tool that I wrote, which is just a simple finite state machine, will chunk nouns together, and then you can reference those as heads. So you don't have to go through the complexity of that thing. You could just do a chunking pre-step and then a retokenize in Spacey, and then use the compounds as your nouns, and then weight those together.
Fantastic. Do we have any more questions? Oh, Alex is back. You're getting the points today, Alex. How does this deal with technical texts like the Solr reference guide? I wonder why you're asking that question, Alex.
I don't know. And here's where I'll get into my big caveat, right? So these things are models. I didn't train the model. The model is trained on Onto Notes 5, which is comprised of mostly readable text for humans. And I think also speech recordings, transcribings. So things like news, Wikipedia, that kind of stuff, right? So if you've got some crazy domain specific stuff like the Solr documentation or, the Federal Code of Regulations or PubMed or something like that, that has a lot of vocabulary and form that's not used in the out-of-the-box Spacey model, you're going to have trouble. So that's why you can tell it what your model is. So you could train your own Spacey model. The courses.spacey.io link walks through model training. So you could train your own Spacey model and just reference it in here. It's actually, so this is a model you can download from the web, from Spacey or from Explosion AI. If you wanted to reference your own model, it's just a path string. So just like I've got this /plugins, you could put a /my fancy model, like right here. And if it's a spacey model, it'll work.
Fantastic. Okay, Suzanne, you're next up. Would you like to ask your questions?
Yes, can you hear me?
Yes.
Yeah.
Hi.
So how could I adapt it to non-English languages, the Hello NLP?
Great question. I'm sorry, I only speak English. I've written this with English in mind because that's my first and only native English. Well, I like to say I speak English and bad English, so 2 languages, like the guy from Die Hard. But there are other spacey models for different languages. There's a lot of community support for different languages. So depending on what your language is, you could find out what the model name is and drop it in here. So I think like for Spanish, it's ES, French is FR, things like that. So I think French, German, Spanish, Italian, like the Romance languages, and I think Russian and maybe even Chinese and some other Asian languages are supported. Visit explosion.ai and see what languages they support, because they do have a lot of out-of-the-box models. That being said, you know, when I was writing this, if you look at, you know, how I'm looking at stuff with the dependency parse and things like that, I don't know how dependencies are parsed in different languages, right? So head nouns may be tagged a different way. I'm not sure. So if you're doing that, you probably want to have a look at the payloader and see, you know, how your language is structured. It's pretty easy, actually. I didn't show this, but I've got this notebook here. This isn't open source. It doesn't need to be. It's just a couple lines of spacey. But you can see that it's pretty easy to see relationships here. So I've loaded my model, and I can just type in text, and I can see what it looks like. So I would encourage you to just get started with spacey at first. Download your language model, play around with it, see how it's parsing. If it looks accurate to you, do some testing, label some data, and see if it does what you need. I do believe spacey will publish their Onto Nodes training results. I don't know exactly where, but I think that they'll talk about accuracy in certain things depending on the language and model that you are looking to use.
Yeah, I have actually used the spacey model for German already. Okay. And unfortunately, the Lemmatizer is not so good, but you can plug in other Lemmatizers, and so it's very extensible. But another problem I have in e-commerce, the product information often is only one word. So the most important field is usually category, color, and title, and they are only maybe 1, 2, or 3 words. And I cannot do part of speech tagging, so I can't do lemmatizing, and then all this, yeah.
Yeah, in the content you probably can't, but when somebody queries, you know, that's a really interesting thing. So if I did a search for like the shirt without stripes, for example, I have no idea what that is in German, but you know, you may have a category which is like, you know, shirt, and then you might have an attribute like style, which is stripes. So you could parse the query and then route the query how you want. So you could do filtering and boosting and things like that. E-commerce is always a challenge with these things. I didn't show a duckling example, but duckling is a really, really powerful value entity parser that recognizes dates, currencies, measurements, a lot of the things that people will use when they're doing e-commerce searches. So like, I want to search for a price, you know, I want to search for a certain size of something. So duckling is actually a nice tool to be able to throw a bunch of text at it, get back the named entities for the values that exist there, and then you can further parse that. So the way that you would integrate that with Hello NLP is you would use the requests module to do a service call out to duckling, which is its own service. You could host it on the same server and another one in a different container. Or you could use the async the AIO HTTP to make sure your async is working in a performant way. And you could go out and get that stuff and then use that further in your analysis chain. So I did want to write a duckling example. I didn't have time before this talk. But yeah, there are a lot of ways that you can use this beyond just parsing text in your content. You could use it for parsing queries and looking deep into the queries and finding what the intent is in the query and what the attributes are and the modifiers, and routing the query in an appropriate way, which is very often a challenge with Solr or Elastic out of the box.
Thank you, Suzanne. Hassan had another question. Is it possible to use payloads with Elasticsearch?
It is. I was right in the middle of writing my payload query when we started this talk. And where is it? It's in here somewhere. Vector something something. I must have closed it. Let me see.
I want to say that Max has promised more on this library in the form of blogs. If you're not already following us, our Open Source Connections blog, I'm sure this won't be the last time we hear about all this stuff. So all the things that Max couldn't fit into his talk, I'm pretty sure will appear in future blogs or even future talks.
So this is kind of an almost working painless script to grab the payloads. Josh Devins is on the call. He should know. But yes, payloading, scoring is possible. I haven't got there yet. But send Josh a note on Slack to ask about payload boosting in Elasticworks. Sorry, Josh.
I don't know off the top of my head, but yeah, Slack me. I'll look it up. I'll find someone who knows.
Yeah, if you're not already on relevant Slack, do jump on where you can ask us questions about this stuff. And also people far cleverer than us will also be able to answer. The links in the chat. So we have a last question here. Could you, Eri Bero, could you please tell us about the status of the vector search and its integration with Solr Elasticsearch?
Oh, so the vector search is supported in Elastic. It's kind of hit and miss with Solr. There's a great blog post on the vectors and search channel in Elastic that has, it's a comparison between Vespa and Elastic on vector-based scoring and boosting. And there's an Elastic demo out there somewhere. I think Maya's on the call, but Maya wrote a lot of the Elasticsearch vector stuff a year and a half ago, I think. So I think the status of vector search in Elastic is okay. I don't think it's amazing. I think that there's a lot of stuff. The problem is you're trying to store vectors in Lucene data structures, and that's hard for various reasons. You also lack GPUs and other things that make the things much faster. Java isn't the best at doing the performance related stuff. Solr, I think, is doing not nearly as well in this area. There are a bunch of efforts out there, both at the Lucene layer, started by some Solr committers, and also Trey Granger had an example using streaming expressions. But their examples, they're not for the faint of heart. You have to spend a bunch of time like building plugins and sticking stuff in there and getting things to work in a custom manner. Personally, I wouldn't go down the road of using a Lucene-backed engine for vector search yet. I would probably use another tool that supports approximate nearest neighbor search as a supplementary database to your search engine, and do things there, and then get the scores and then merge the scores somehow. So maybe send the score in as a parameter in your query, like do the ANN first, and get the score back against your top 1,000 documents or whatever, and then use that score if you see it in the recall for for the results that you get back from your Lucene-based engine. there aren't amazing patterns on this yet. The other interesting thing that's a great question. And, you know, we could talk about this for hours, but one of the other reasons I started on this project is I was seeing a whole bunch of other little search engines popping up that tried to solve this problem with vector search and doing similar things. So there's like Gina AI, there's interestingly a new search engine called Haystack, which is kind of funny. Those are open source tools, and there are a couple of others out there that are like new search engines. And there's also Answerini and some other things. But the reason I did this is because nobody's going to migrate their search engine to be able to use the vector search just yet. Unless you're probably migrating to Vespa, which I think probably does the best job of all of them on this right now, because they've been doing it for a long time. So I was like, well, nobody's going to drop their big Elasticsearch cluster or Solr cluster and switch to Gina.ai right now. You just have way too much business backing this stuff. You don't want to replace your search engine. It's like replacing your database, you know? I want to treat search like a really, really fancy database, but you want to have a lot of other nice stuff that you want to be able to do with it that currently isn't, you know, possible in a packaged manner right now. So that's the reason that I wrote this library, is because I wanted the folks who are running Elasticsearch and Solr to have something that they can use as middleware that does a bunch of stuff, so they don't have to switch to another search engine to have, you know, NLP capabilities. But again, going back to your original question, I don't think that the vector search is solved just yet. But you can try. And if you do try, please share your results. We'd love to see it.
Fantastic. So Max has just popped up our closing slide here. So do join Relevance Slack if you're not there already. The video of this talk will be up on YouTube as soon as we've processed it. There's lots more there, including all the talks from our previous Haystack conferences that were videoed. Join the meetup, and please do spread the word, and get using Max's tools. And I'm sure he'd appreciate pull requests, and he'd appreciate feedback. Issues. Try it out, write some stuff up. We've got more events coming up. The next Haystack Live talk will be October the 15th with James Rubenstein of LexisNexis talking about building a data-driven search program, which I think is going to be a fascinating talk. If you haven't seen James's posts on Medium recently, do check them out. They're fantastic. Really about the process of relevance tuning. And then we have our trainings, of course. If you want the Solr training next week, get in quick. Hello Learning to Rank on the 20th of October, and natural language search on the 17th of November, taught by someone you may recognize. Yes, it'll be Max explaining the mysteries of natural language search to you. So do check that out. And also, I will give you very early notice that we may, nothing's confirmed yet, there may be some kind of Haystack event before the end of the year. That's all I'm going to say. I will obviously give you all notice as soon as I possibly can. But we're hoping to try and keep the community going and get people meeting and talking about search as much as we can. So yeah, thank you very much for everyone for coming. And thank you, Max, for being our speaker today. And we'll see you all next time, hopefully, on October the 15th.
Thank you so much.